Okay, oh there we are. Alright. So, alright. So as you can see for the title today, we are going to write some shaders. Yep. So over here we have a shader that I've been working on like when few days ago. I kind of forgot. Oh wait, June 6th. Yeah, yeah, that's the date when I work on this one over here. Like, this one is actually quite interesting. It's like, it has something to do with sign distance function. But, today we're just going to like, upgrade on one of the shaders I've been working on, which is Queasy shader. Let's see. Because the thing that I'm going to add is what I call vector mask. So let's focus on that. This one. Let's see. So let's throw this thing in. Alright, so this is what Queasy shader can do right now. Like, if we take a look at our inspector window over here. Oh wait, I think I should like change size. So this one be over here. Inspector should be over there. Alright, then let me close this tab. There we go, perfect. Hierarchy on my head. Nice. Alright, so if we take a look at this thing, we only know that our main texture over here, we have hibiscus chan over here in layer 1, and then no distortion, no mask texture, and main texture is not affected by any of the complex color layers. Like, it's not influenced by vector color and Fresnel or Wenzel in this shader. For layer 2 we have this like simple background whatsoever it is, and then the only distortion is Perlin noise, and then we have no masking as well. So it's basically like that. Now this feature over here is actually something quite new, because before the update we only have one layer blending mode. So the layer blending mode is down here. The original and default layer blending mode is channel add, which is something like for the two layers you add up the channels. So for example, layer 1 channel red plus layer 2 channel red, and then green matches green, blue matches blue, alpha matches alpha. So this is the default or the original one before the update. And then just a few days ago I just added a new blending mode, such that you can do something almost like Photoshop layering. So, but of course we only have two layers to work on for now. So we have stack layer 1 first or stack layer 2 first. So if we were to go to stack layer 1 first, meaning texture layer 1 is going to be on the top. So as you can see, hibiscus chan is on the top, and then we have layer 2 as the background. Now if we were to choose stack layer 2 first, then layer 2 will be on top and it will just block hibiscus chan in this case. So let's go back to channel add 1 first. Alright, we'll have that. Now, for the effect to take place today, the thing we are going to focus on, we are going to mask our vector color. So what vector color is? Alright, we are going to add a new, let's create a new empty 2023. Today is June 9th. Am I right? June 9th or June 10th? Okay, June 9th. Alright, good. So we're going to do that over here. So right click, create, let's create a sphere or whatever it is. So the thing we're going to focus is sphere. Alright, so let me just hide this thing off because we're going to focus on this one. There we go. Now, you know what? We can just like alter this thing. So, by the way, we can just say I'm just going to reset this whole thing, and so now it's just a white glowing blob whatsoever. Now, set this to 0. No glitters. Clamp the lerp, yes. Blending mode for now it's default. Alright. So the main idea, okay, Fwenzel influence. Okay, let's not use that because Fwenzel influence already has its own mask. So what the vector color can do is, if we were to crank the influence up, you can see it disappears. Don't worry, it is supposed to happen. Okay, now we have that. If we were to go to vector color, here's the vector color part. The main idea would be something like, based on the normal that face is facing, it'll get colored differently. For example, if I were to choose the color red over here and then I choose the vector 100, if I were to crank up the strength, you can see, oh, it get colored up. So the main idea would be something like, if the normal vector is like pointing to the x-axis, then it will get colored red. As you can see, as the normal is pointing away from x-axis, then it will get colored less. So if we were to like choose green over here, like 120, and then I set it to Y, then if we turned up the crank, then we have this. Now, so we have red along the X, and then we have green along the Y. Now, if we were to go to the front, we still have nothing yet. So let's add one more thing. The next one should be blue, which is 240. So over here, crank up the strength. Oh wait, that didn't work. Oh wait, because I haven't give it a vector yet. There we go. Alright, so it's 001 for the vector. So we have red on the X, Y, no, green on the Y, and then we have blue on the Z, and then you can see they're getting blend in the middle, which is perfect. If you want a very sharp edge, you can crank up the ramp. Oh no, wait, cranking up the ramp makes it a little bit more focused. If you want very sharp edge, you have to crank it to 0. Now the only problem is, if all of them were to be 0, then you're gonna have this like weird cutting shape. So what you can do is, instead of exactly 0, you can let it approach 0. So for example, 1 divided by 1000, or 1 milli. And then you can have this. So we have red, yellow, white, magenta, and cyan, and blue, and of course green. And as well black, because this is where all the vectors gone 0 or whatsoever. Or we can just go back to normal 1. There we go. So the main idea, like what we're going to do today, is to like add a mask on every vector color. So the problem would be something like a single mask. If you take a look over here, a single mask has all of these parameters. So this means that it's going to get messy. It is going to get messy. So I'm thinking like, should I do like one mask texture for all the vector colors, or am I going to have all the mask texture for each vector color? So that is something I have to like decide. That's a problem. But yeah. Anyway, if we go back here, yeah, there we go. Let's see, how are we going to decide that? Oh boy, this is going to be hard. But the main idea is, if it gets masked, then the color should be the purest. Otherwise, it should be cranked to 0. So that's the main idea of the mask. You know what? Let's start with one mask, because oh boy. Let's start with one mask. Or should I? Now the only hard part is, if only I know how to make collapsible sections, then I can make things work. Fine, let's do that. So here we have Queasy Shader. Right click, show in Explorer, and we are ready to go crazy. Or in this case, we're ready to go queasy. There we go. We go. Let's scroll down. Alright, as you can see, it just becomes colorful automatically. Oh! Release notes. Huh. Okay. To be honest, I have no idea what's going on. Oh boy, this looks Mac-ish. Oh boy, you can see those rounded corners. It's definitely Mac. Alright, yep, it's a Mac. We have the red, yellow, and green on the top left. But yeah, I'm not gonna look at that. We are going to focus on this instead. So let's find Fresnel. Oh, vector color, there we go. So if we look at that, then let's see it side by side. We have our mask over here. Alright, good. Alright. So we'll have that vector color. Alright, there we go. And then we will need space 64. And then we'll just have those copied over. So we have vector color layer oh boy. But also at the same time, wait, no, okay. I wish like we can have like sliders inside of vector 4. That would be cool. Let's stick with one mask for now. Because if we have way too many masks, then this means that it's going to get messy afterwards. Like very, very messy and hard to navigate afterwards. So we'll call this mask. Alright, image. Mask texture. It's a 2D. For now, it's gonna be white by default. And then the next is the T mod, or transform mode, which is something extremely new to other shaders out there. Although it's a float, it needs to be something else. Let's set that to 0. Because it's not like exactly every time you're gonna need that. The T pose or position. We have transform pause. You know what? Basically, we can just like copy and paste stuff. Alright, let's copy and paste. And then let's copy that. So let's replace that. There we go. And then the next thing. You know what? Let's just copy the whole thing. There we go. And then we will just replace each of them by using that. Just in case I may be dumb, maybe there is a certain way to do this like really quick, but I'm dumb. Yes, if you know how to do that, please type it inside the chat. If you don't know, it's okay. Let's focus on the main thing. Oh wait. If we are going to use only one mask, oh wait. Oh, that's something not good. Well, this means that we will need to have multiple masks. So, let's close this thing. And let's hit save for now. Of course, Unity will not be happy, because Unity's gonna be like seeing all of these new stuff all over the place. Like, where does this thing come from? I don't know. And then, yeah. So, alright, what we're going to do is to insert every single one of them. There we go. Vector color 1, vector color 2, vector color 3, and vector color 4. Now this one over here should be 1 all over the place. Here we go. There we go. Alright. So, so for this one, we have that. Vector color, and we have this. And then we have that. Go, and then we just need to like rename this to layer 2. And then over here we have 3, so we're just gonna rename that. Oh boy, soon that graph is going to be complicated. And finally, vector 4. The space 64, we don't need that. Alright, there we go. 4, 4, 4, 4, all over the place. So in the end, yes, we are doing we're doing something like for every vector color, it's going to have its own mask. Oh boy, it's going to look messy as heck. Now we are ready to declare the variables. to NVIDIA, or I'm not quite sure, but anyway. As you can see, we have a lot of stuff going on over here. Okay, that's the vertex part of the shader. Is this? Oh, okay. Fresnel vector. There we go. So let's see. So for the vector, currently we only need this. And then let's focus on that. So let's paste that. Now it will be weird, yes, but we'll fix that. And comment it out, all the things. Alright, and then alright. Is that like sample 2D, right? Sampler 2D, yeah, we have that. And then the next thing is float. And then all of these are vectors. And then this one over here is a float, 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 and float, 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 float. And all of these are floats. There we go. And then let me get rid of that, because we don't need that. Next one is what we're going to have is a vector. So copy that. Paste, paste, paste. There we go. So we have this. This means that we can turn off the window on the left. So let's close that. Alright, there we go. And then let's hit save. Don't want to lose any progress. Let's see. Wow, okay. There we go. And then there we go. It's one more. Okay, so 4 over here is perfect. So this one over here should be 3. Boop. And we'll go all the way down. Oh boy. Alright, almost gone wrong. There we go. There we go. So that's for all the 3s. And then for all the 2s, let's go ahead and do the same stuff. There we go. There we go. Alright. So that's for 2. Now we have 1. Go. There we go. Perfect. So now we have all the things ready. Now we're just going to split our screen again, but also at the same time don't want to lose any progress. And we haven't do anything yet, but we need to make sure that our thing runs fine. So let's go back to Unity and see if it becomes magenta. Yep, there we go. So we have a problem. Okay, let's see what it is. Oh, there we go. Syntax error, unexpected token float. 1599. 1599. Oh, okay. It needs to like have all the things. Okay, I see. It needs semicolons. Here we go. And then the rest is like there we go. And then like, it's actually quite fair to have a semicolon in order to tell the compiler, hey, this is all the statement. So, yeah. So let's head back to Unity and see if it's normal. Or what's the next error that we're going to have, I don't know. There we go, perfect. Yeah. Alright, anyway, let's go back here. So this means we can finally implement that. So we'll turn this thing off. Oh wait, no. Okay, we'll leave that thing open because we still need to like refer to it. But we can start working on stuff down here. Vector color. Yep, there we go, vector color. Originally we have these simple paths. Let's see, okay, Alright. Okay, let my brain think a little bit for this one. thing that we need to do is to like we need to end up alright, let's take a look at how did the other mask end up being used. So let's split our windows again. Oh boy, this is going to be messy. Let's take a look at our other get mask as well. So what is this? Oh. Ah, there we go. Here's the mask. Okay, just in case, you're going to hear me eating chips at the same time. But, yeah. Oh, we only have this like if-else layer. Then we don't need to care about the optimization. Let's change this to pass 2. Pass 2, pass 2, pass 2. Okay, so we have pass 2 over here. Pass 2. Pass 2. Pass 2. And then pass 3 in this case. No, wait, still pass 2 over here. And pass 2. And then pass 2. And pass 2, because we're going to use pass 1 for the mask final vector final. Pass 2, pass 2, and then pass 2, and pass 2. And yep, we have that. Vector final. Yep, we have that. So, excuse me. Oh boy. Let's take a look at the mask. So, get mask color. Alright. Here we go. First, it's a fixed 4. And then we can know it's a vector color pass 1. Pass 1 of 0, so that is like getting the color of it. Get mask color. The next thing is invert the mask, so it's another fixed 4 vector CR1 pass 1 of 1 invert mask. The next thing is threshold cut, so which is another fixed vector CR1 pass 1, okay, 1, and then pass 1 off 2. This is the threshold cut. There we go, and then we have fixed for vector CR1 and then pass 1 of 3. This is the calculator filter power. Oh wait, it's not fixed for, it's float instead, so very good. Float. Mask filter power. There we go. Alright, let's hit save. And then we just need to like copy and paste for every channel. Alright, 4, 3, 2, 1. There we go. And then invert the mass. Here we go. 1, 2, 3, 4, 3, 2 as well. And then Control C, threshold cut. There we go. And then we'll just have that, that, and that. And then finally this thing. The filter power. 2, 3, and 4. Alright, so we have that. Now we can focus on the mask calculation. Oh boy, it's going to get messy. Anyway, alright. Let's see. Alright, so let's take a look at that. Oh boy, we're going to keep on splitting windows. And then now we're splitting windows into 4. You, go down here. Oh boy, look at this. This is the messiest screen I've ever seen. Anyway, where is it? Thing I'm looking for is 2092. So keep scrolling down until we have 20. Okay, I can feel it. It's somewhere else up here. There we go. Because I want to look at this, but also at the same time I need to look at this. So, alright. Alright. The first one is we read from the texture. And then to read from texture, we need to get this. So, paste that. Equals forward. Color, read from texture. And also at the same time, let me add an extra tab for that. There we go. Okay. Um, okay, the first one is that thing. Copy and paste from those. Oh boy. Alright, this is the one. Got it. One is over here. 0. What does 0 mean? I kind of forgot. Oh wait, okay. The 0 over here means either we're dealing with a vertex shader or a fragment shader. In this case, Quasi shader does both, but here is the fragment part, so it's 0. If it were to be 1, then it's for vertex. So instead of text 2D, oh wait, so instead of text 2D lot, we are going to use text 2D. And yes, there are differences. So incoming dot uv dot x and incoming dot uv dot y. So we have that. Next thing is transform the pose. Alright, there we go. Dot x dot y dot z dot w, and then we are going to do the same stuff as well. So spacebar, spacebar, spacebar. There we go. The next thing is rot, which is rotation. There we go. There we go. And then X. And then Y. And then Z. And then W. Oh, I almost forgot. We need a comma up here, comma down there. Alright. Next thing is scale. Alright, paste that. X, Y, and Z. Just in case, this read from texture thing is a self-made function. It is not built in. So yeah, don't take for granted for that one. And then we have skew X, Y, Z, and W as well. Alright. This thing. Dot X. Dot Y. Dot Z. Dot W. And then finally we have our T mod. So let's paste that here. Alright, and then we are done for read from texture. So let's save that. Step 2. Oh, that one is invert. Yeah, it's invert. So let's have that. For invert, I remember just simply looking at this, we are actually looking at blend 1 minus. Or, oh wait, no, it's not blend 1 minus, they're different. Okay, they're different. Pixel 1 mask 2. Oh, okay, so we are, okay, so we have pass 0, now we have pass 1. Okay, so vector color 1 pass 1 of 1. Okay, so this is invert. So this thing basically equals float 4. And now we're just gonna dump everything inside. In this case, for war lerp simple. Alright, meaning get that number. So we will just copy this thing. Paste it over here, and then dot red, and then 1 minus this thing dot red, and then we need the crank from here, so it would be this one. After crank it, we just need to take a look if we clamp the lerps. Because if we don't clamp the lerps, yes, we can extrapolate. And then let's have a comma back there. And then we're just gonna copy and paste this entire line, but change some of the stuff up. Alright, there we go. So one over here is RGB G B A B G and then G B A, and there we go. So this is what we will have. Now the next step is the threshold. Okay. Let's see. Okay, so oop, there we go. So vector color 1 pass 2, I guess? Yep. Okay, it's a yes. So meaning this thing, threshold, so float 4 again, and then we have forward lerp crash. Okay, then we have low, high, and then 0 and 1, and then the previous pass. Okay, so we will have take this thing over here, which is the low part, and then this thing over here, which is the high part, and then low, high, 0, and then 1, and then the previous pass, which is this one. Previous pass, and then the channel of that, and then a comma. And then let's just copy and paste the whole thing. So let's see. Oop, oop, oop. There we go. Perfect. So let's change up the name. G B A, and then we have A G, no, A B and G. So RGBA, RGBA, and then we have 0101, and then yeah, and then G B and A. Alright, good. And then remove that comma. Now when we okay, now it's time to calculate the pixel power. So, or I should say the mask power. So for the mask power, it's actually plus 3. So vector plus 3 vector color plus 1 of 3. There we go. Equals alright. Here we go. This is going to be a long one. The previous one red, okay. Control C. Dot R plus dot G plus dot B plus dot A. Now we just need to multiply those numbers, and those are from the user interface. So let's get those. Ooh. And there we go. I'ma just use my arrow keys. I don't care. Where is it? Oh, there we go. Alright, multiply by that. Multiply by that. And then multiply by that. And finally, multiply by that. And then semicolon. Oh, I almost forgot semicolon up here, semicolon over here, and semicolon up there. Oh boy, we were so close to death. There we go. And then once we have that, we will take account of this as well, which is the filter power. Alright, so let's hit save, and let's head back to Unity to see if it is doable. And no. 2108. Well, let's take a look at that. 2108. Oh, there we go. What's the problem here? Ah! Okay. So let's remove that. And it should be good. Okay. There we go. Well, there we go. Oh, wow. Okay, this is like weirdly shaded. Alright, fine, let's take a look at that. So, let's go down to vector color. Alright, there we go. Let's see if it works. So, let's pull in... you know what? Let's have this. Oh. Alright, fine, let's take a look at this. Okay, so it works. It works. Okay, so it works. Now the only problem is, if all of them are cranked up to that, well then, it's going to be bright, like as you can see. Because all the channels are masked, then they're just gonna add up. So yeah, we'll fix that. Or maybe we don't even need to fix that, because it's built in that way. Alright. So, all we need to do now is to implement this for every other vector colors. Oh boy. So, I'm just going to mute my mic, but at the same time, I'm going to work on this same thing, but for other vector colors. So yeah, here we go. Yes, I'm still here, so if you got any questions, type in the chat. I'll just go back here and then just answer your question as well. Yeah. now we just need to let them calculate that. Where is it? And then we just need to like let it like consider the last pass into the final pass as well. So here we just need to type in, or I should say copy that, and then yeah, that's the thing. And this one over here. This one. Over here. There we go. And then chances are it's going to burn our eyes. In 3, 2, get your sunglasses ready. 1. Oh, okay. Let's see what's the problem. Undeclared, unidentified vector color. Vector CR2 pass 1 of 0. 2131. Do we have that at the very front? Pass 1 of 0. Vector CR. Oh wait. Oh. Alright. There we go. My bad. There we go. 3, 4, 2, 3, 4, 2, 3, 4, and 2, 3, and 4. There we go. Now let's head back to Unity. This may take a while for Unity to crunch like what's going on. Okay. So let's give that a try. Let's see. For the vector color, we have that one for red, and then for green, let's have this one. And then so we will let red be the mask. Okay, and then the next one, fine, we will have that. And then we will let red be the mask again. So, alright, let's try to like, because that doesn't look right. It looks unaffected. Is it? Okay, so there is something wrong with number 3. Let's take a look at that. 3. Huh. That is weird. Or wait, what would happen if I change another one? Say this one. Oh yeah, then no problem. So it's not the shader's problem. Instead, it's the texture's problem. If we take a look at this is butterfly. Oh, there's a probability such that it is white all over the place, but the alpha makes it different. So instead of having red as the mask, we will have alpha as the mask. Now we're talking. Okay, okay. Now that makes sense now. So if we were to turn the others back up, now we have this. So yeah, this means all the vector color now is going to have their own mask. Okay, the original intention for this is actually because let's see if we can search it on Twitter. Let's see. I'm trying to find. Let's see. Where is it? Oh boy, as you can see, if I were to pull out Twitter over here, you can see I'm trying to search something from Unity Shaders Bible. Where is it? I remember there's a post about that. We are about to do something similar to this, but totally different. No, not that one. Torch flame. Oh. We'll take a look at that. Okay, this thing over here is cool. Is this the thing? Oh. No. Okay. Okay, we are about to do something similar to this, What else? Is it this one? About something similar to this, but oh boy, let's see if we can like find the things we need from here. Aha! This thing down here, such that oh, okay, it just goes away automatically. But as you can see, it has this like watery effect on top of that. So you can see why I've decided to add that mask layer, because what we need afterwards is just Voronoi. Wait a second. If that is the case, then this means it needs distortion. Oh no, and then so we need distortion to distort the mask? This is getting weird now. Let me think. Wow. Hold up a second. Hold up a second. Can we replicate that without even using the mask layer? Okay, so question one would be something like, do we even have a Voronoi noise texture? So let's take a look at that. And oh boy, there we go. Okay, this looks good enough, I guess. Oh wait. You know what? I prefer this one. So, what we are going to do is let's use none for that one, and none for this one, and none for this one, and then all of them will just go back to normal. And then vertex color strength will go back to 0. And okay, we're going to use that. And this will go to 0. And then so the light, let's go with this. So we have that. Okay. If that thing is getting influenced, then if I use this, then this means that I will use T number 8 on that. Holy mamma mia. Okay, so we have this. But that might not be the case. Okay, let's choose another one. So, in this case, let's have somewhere from up here. Yeah, let's have that. So we will have this, and then for the second layer, yes, this is where the second layer comes into play. And then we will grab in that Voronoi. Where is it? Oh, there we go. Okay, that's a little bit too right. So huh. But we want it to be like vector-ish. So get affected by vectors. Aha! In this case, we're not even using masking. Okay, so maybe the mask is an extra feature we have added. Like, we can move this thing around. And then we can just like move this thing 0.1 or something. Oh 05, yeah, something like that. And then we can like distort. So in this case we need purlin. And then along the Y a little bit, so it's 0.1. Oh boy, that's a little bit hard to see, but it looks good. In this case, let's crank this thing up a little bit. Okay, cool. So yeah, we can do that. Oh, to make it even more watery-ish, we are going to use the color blue or cyan instead. Hey, you know what? Let's add more colors. Let's crank that up. And also 0 and then 1. In this case, let's make it slightly weaker, and then the ramp, let's adjust the ramp to be a little bit more focused. Look at that! We are not even using mask, but we're doing the things we want. Okay, so we will consider the mask as an extra feature. Okay. So yeah. I'm getting potato chips, yeah. Good. Yeah, it does pick up. Oh, simply looking at this looks good. Now, this marks the very first checkpoint for today. So yeah, this marks the very first checkpoint for today. So let's update that thing. Alright, so what I'm going to do, if I were to do something like, let's see. There we go. Alright, let's hit save. This is inside shader experiment. Alright, so let's close that. Oh wait, it's already in Explorer. Alright, so let's copy and replace that. Alright. Now, let's focus on the second checkpoint for today's stream, which is a very specific shader for Voronoi. So, let's create a new shader for that. In this case, we will turn off the sphere because currently we don't need that at the moment. What we need is the quad. There we go. Look at that. Look at that. Alright. So color crunch. Let's reset that. And yes, it will burn our eyes again. We are not going to do this in Queasy Shader because it will get messy. However, if we want to implement that inside Queasy Shader in a future version, then yeah, we'll do that. But now let's focus on a single shader to do that. To deal with Voronoi. So, Queasy specific, Queasy rad, Queasy temp. So let's copy and paste that. There we go. And it's not temp anymore, instead is Voronoi. There we go. So Voronoi. Create. Let's show that in Explorer. So the main idea for that shader is going to be, it's going to able to like generate a Voronoi texture on top of that. And then we have our stuff ready to go. Let's minimize that and then minimize that. Okay, so let's choose this. And then it's not temp. Instead it's Voronoi. So let's throw in our this thing. This is the radius shader, I call it that way. A very specific, not as versatile as Queasy shader. As you can see, we have red over here. The next thing, Voronoi. So yeah, this is the default output. We have red along the x-axis and y along the y-axis. So we'll have that. Alright. Because it just outputs that. So now, Voronoi. Okay, first let's try to find some examples because I personally know what it is, but it is easier to explain by using examples. So, Voronoi. Aha! Wow, that is a little bit different from what I was expecting. However, okay, let's take a look at this, for example. So the main idea would be something like, oh boy, I don't know if you guys can see that. So let's open this image in a new tab, and then let's just zoom in. So you can see over here there are different points across the canvas or whatsoever. We have different points across the canvas. The question is, if I were to drop you on this plane and then I want you to immediately find your closest point, then which point would it be? So what Voronoi does is something like, if I were to drop you somewhere around where my pointer is pointing, you can immediately, the region tells you, hey, this point over here is the closest to you. So you just go here instead. So that's the main idea of Voronoi. Basically, it's something like which vertex is the one which is closest to me. Basically, it's just asking this question a bunch of times. So, now the problem would be something like, how can I like immediately detect a point without calculating all the points distance? So that's a problem. We need to figure it out in this way. So, basically, I'm thinking, what if we do a while loop, and then like we have an increasing radius from that, and then once it detects a point, then once it detects the point, then it will get colored by that point's color. So let's try to do that. Okay. Let me think. Thing we're definitely gonna use is we are going to need a bunch of points. So I don't know if we can have a vector 2. So let's try this. Vector 2. Not quite sure if we are going to have that working. Wait a second, where's the interface? Ah, there we go. No wonder it feels weird. There we go. Let's see if Unity even picks up what I meant by vector 2. Yep, it didn't pick it up. Yep, it didn't pick it up. Yeah, unexpected TVALID. Okay. So it needs to like stick with a vector 4. Oh boy, that's a sad thing. So if that's the case, then fine, vector. Well, then this will be basically something like, okay, so we have the position. What else I can like implement inside a single point? Like a single point can have its position. And also its color. Oh, what about its strength? Huh. I don't know, but let's go with 0 for now. And let's aim for 16 points. I'm thinking. Yeah. .1. Or I should go for .0. And then we can count in hexadecimal. And then, yeah, V all over the place. Alright. Oh boy. Okay, me crunching that thing is cringe, so I'm going to mute myself. Colors. Let me do an experiment. What will happen if I do this? Okay. So it's expecting that. Oh, so it's expecting 4 numbers. Yep, it needs to be like 4 numbers. Oh boy. Yep, and then now we need colors. And then oh boy. We will decide which color it is. Alright, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, and F. Oh boy, one more. Okay. Let's remove that, and then let's go with F, E, D, 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 A. And then 9, 8, 7, 6, 5, 4, 3, 2, and 1. Alright, now we have to figure it out the color for every one of them. Well, this one's definitely gonna be white. Oh, wait. Okay. You can see I'm counting in binary now. There we go. Let's go. Just in case, if you don't know what binary is, it's basically base 2, meaning once you count to 2, you will carry to the next digit. And turns out it has this very special, elegant pattern, which makes binary search so much easier. Did I messed up? Yes, there we go. There we go. Alright, so we have all the points and all the colors ready. So, let's hit save. And let's see what will Unity look like right now. Definitely something, Okay. Okay, we can work with that. We can work with that. Okay. Yeah, it looks very ugly right now. But yeah. Since it's just 16 numbers, it should be much easier than Queasy Shader. So we will use the naive way then. But the question would be something like, I don't know if what data type can a shader hold? Let's see. Can it hold a vector 4x4? I hope so. Let's see. Shader data type. Aha! We have float half fixed int sometimes. Oh, we have a float 4x4. Okay. Float 4x4. Is there an example to use 4x4? Okay, let's see. Float 4x4. Let's see if we can find anything about that. Oh! We have a struct. Oh, so 4x4 is just a bunch of singles like that. Name. Oh. Oh, wow. Oh. So it's name M00, M01, M02, M03, and so on. Okay. Okay. Let's try to use that. So, here we go. Float 4x4. It's blue. It's blue. Oh no, it's blue. Let's go. Let's call this distance matrix. Okay, equals something. From M00 to M33. So let's start calculating the distance. So let's define a small function. Oh, wait a second. Hold up. Hold up. I almost forgot one thing. We need to declare that. So, back there. And then let's copy and paste again. Whoops. There we go. Alright. And then we will have 0.1, 0.2, 0.3, and then 0.4, 0.5, 0.6, and 0.7, and then 0.8, 0.9, 0.10, which is A, and then 0.11, which is B, and then point C, which is 12, and then we have 13, 14, and 15. So we have those. Another thing is color. In this case, it's actually fixed 4, so we'll have that. Excuse me. Oh boy. Okay. Fixed 4. We have this, and that. Boop, boop. And one more. There we go. And now let's have that. So 4, 8, C, D, 9, 5, 1, and we have 2, 6, A, E, and then we have F, B, 7, 3. Okay, so we have these. Now let's make a small function just to calculate the distance. So we'll call this forward again. It will return us a float. Distance. So in this case we need float 2. Let's call this point A, and then float 2 point B. Okay, then it will return us a float or whatever. So what we need is point A dot x minus point B dot x, and then we will just to the power of 2. Oh wait, whoa. Okay, pow to the 2. Now another pow again. This time it's point A dot y minus point B dot y, and then to the power of 2, and then pow this whole thing, and then 0.5. There we go. So it will return us that. Okay. First we have our UV, and then we need our points. This case it's like points and then the ID number. Okay. X and Y. There we go. And then we'll just scatter this thing across the whole thing. And also let's there we go. Okay, so this is 4, this is 8, this is C. Okay, there we go. And then this is D. This is 9, 5, 1, 2, 6, 10, which is A, and then E over here, and then we have F, B, and then we have 7, and then we have 4. So we have this. Now we just need to like pick the minimum distance. So what will it do is it will return the float, and then we call this 4x4 min. What it will take is a float 4x4 matrix, let's call it that way. And then what will it do is going to be min. So it's going to be min of, oh boy, it's going to branch. Or can min take multiple arguments? Can min do that? Let's try that. Nope. Let's see. Min, no matching tree parameter in string function. Yep. Min can only take 2 inputs. Okay. So, let's take matrix dot m 0 0, and then matrix okay, how about let's just call it this MX or MTX to call it shorter. So MTX and then we have that, and then we need another min, MTX M number 2 and MTX dot M03. Okay, so we have that. Let's make things a little bit easier to read. So let's have float. Row 0 min. So we have that. And then we will just like scatter this thing across. So 1, 2, 3, and then 1, 2, 3, and then 1, 2, 3, and then 1, 2, and 3. There we go. Okay, so we have those. And then we can have return. Oh wait. There we go. Min of hold up a second. Let's just say it returns a vector 4. So basically it's like, yeah, once it returns a vector 4, then we can know its distance. We can get the distance, and we can get the ID. Oh wow. Oh wow, okay. This is going to be interesting. Oh boy, this is actually a really good brain exercise. Like, because I'm thinking now, like, how are we going to get the ID of the nearest point? Like, okay, we can keep on increase. Oh boy. wow. Or instead of finding the min, let's say the more closer you are to a certain point, you will get colored more. But, oh boy, this is something burning my brain now. Like, okay, fine, we have our distant matrix. Let's put that in the storeroom right now, so... Because I'm thinking, what we can do is just like keep on increasing our radius. And then once we detect the point is inside the radius, then we will just return that point. Okay. Let's see. So row 0 min, and then row 1 min, and then we also take another one, which is row 2 min and row 3 min, and then min is that. Now it's a float. MTX min is this thing. Okay, so now we have the minimum for that. So if we have this min, then which means one of the points will definitely have this one. So if we were to use for loop, can we do indexing? But 4x4 is a struct, not an array. That's the sad thing about this. Oh boy. This is going to end up with a bunch of if-else then. Can we even use switch here? Alright, let's make another int in this case. MTX ID. MTX min. Then MTX ID equals 0. And then it's just a bunch of if else. But over here is else if. Okay, there we go. All the way down to that. Oh boy, this is going to kill me. Because it's a struct, not an array, so that's the sad thing about this. If it were to be an array, I can do a for loop. Oh wait. Oh boy, I'm doing it wrong. Okay. There we go. Zero, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, and 3. Alright, let me remove that. Else, if something is wrong, then return something weird. In this case, let's call this 20. I don't know. Alright, there we go. And then the ID just goes on like that. There we go. And then in this case we just need to return a float 4. The first one is the distance, which is MTX min, and then the ID of it, MTX ID. Okay, so we have that. Let's initialize it as 20. So now we have this. So that is our distance matrix. Now let's have a float for it. Let's call this final decision. And in this case it's 4x4 min. And it comes from the distance matrix. So take that, which means crunch all of these numbers and throw it into here, so we will get the minimum distance and it will return us the ID. So, okay. Let's make another function again. For ID to color. It will return a fixed 4. Okay. Because it will return a color. Alright. Fixed 4. This is going to be a long list. Color is 0, 0. Yeah. We need that, and then we need that, and then copy and paste the rest of them. And then finally, the incoming ID. In this case, it's an int. And then we have 1, 2, 3, 7, 6, and then 5, 4, 8, 9, 10, 11, 15, 14, and then 13, and finally 12. Alright, we have that. Alright, let's save this. Okay, it's an if-else statement again. If incoming ID is 0, then let's have fixed 4. Final color. For now, it's gonna be black. Final color is going to be C00. Okay, so it's going to have that. Else if and then it's going to be something else. Did I copy the extra tab? Maybe it's a yes, so that's why it became weird. Anyway, so let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way. Ooh! I got it perfect. 11, 12, 13, 14, 15. Yes. And then we have else final color is float 4, and then that thing. Here we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we have A, B, C, D, E, and F. So we have that. Yeah, we have that. Alright. So for the final decision, okay, then the final decision in this case, x is distance, or I should say min distance, and then y is the ID, so in this case point ID. Z is 0 and W is 0. Okay, so we'll have that. And then we will return the final color it has. So return the final color it has. Okay. Return for ID to color. So in this case, we need all the colors over here. Let's have that. And then the and finally the ID, excuse me, oh boy, which is final decision dot y. Whew. So color 1, 2, 3, 7, B, F, E, B, C, 8, 4, 5, and 6, and A, and 9. Okay, so we have that. Oh wait. Oh wait. Aha. So it can be something like position X, position Y. Is it using this point? So we can either say 0 or 1. So we can use that to encode that. So distance Okay. Let's call that a float. Big constant. Alright, no. Okay, in this case, we will say, big constant is something. So in this case, we will say core, which means constant. In this case, float. Let's go with So we have that. Or is it a good idea? Okay. How about this? So yeah, we have that. Let's have 3 of them say yes, and then the rest of them is just like by default says that. And then you can just remove the 0 by hand very quickly. Okay, there we go. So here's the weird thing about that. However, basically the main idea goes like, once I got this, then we will multiply by 0.00.z. So if it were to be using that point, then it's 1, then it's normal. However, if it's not using it, then it's like it can be treated as infinity far away. So yeah, we can do that. Or if you want to like mess with it a little bit, then yeah. So 4, 8, C. Okay, now um 1, 5, 9, 8. Go. Seems odd. There we go. There we go. 2, 6, and A, and E. Oh, wait a second. Oh, it's capital P. Oh well, caps locks then. There we go, and then, whoops. There we go. P, P, P. There we go. And then this one is F. This one is B. This one is 7. And then finally 4. So we have that. Final decision will be that. And then this one, that one. Not sure if this will work, but let's give this a try. Okay, invalid subscript M00 106. Then how do I use that? Huh. Alright, let's see. Unity shader float. Oh wait. All caps. Okay, Unity shader float 4x4. Oh. Oh. Row index and then XYZ. Let's give that a try. Guess 106 is the one which has problem, right? Or which one? 106, yes, because it's the very first one. Let's say 0. And then we have X. 0 and then Y. Z. Zero and then W. I'm not quite sure how this works. If it changed from 106 to 107. Aha! Okay, so it really needs to use this kind of notation. Okay. Okay. So if this is the case, then this means that... Oh, then... Okay, okay. We can, like... Oops. Any... There we go. X. 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 And then we have Y. Whoops. Dot Y. There we go. And then we have 1. And then we have 1 again. Z. So basically it's like we have float force, but nah. Not sure if this will work. Oh, 115. Ah, okay. Yep, here we go. There we go, and then X, X, X again, and then X, and then this next one is Y. Oh wait, my indexing is also wrong before this change as well. Okay, Z, W, Z, W, Z, W, or sometimes Z or Zek, I don't know. W, alright. Let's see what Unity has to say. Okay, 133. Incorrect number of arguments. 133. Let's see. Return float for. Oh, okay. And then let's go. Unexpected token 204. Oh, definitely because of that. And then let's take a look at this. Not all contra pops return a value. 137 ID to color. 137. Oh, okay. It doesn't return something. So, return final color. So let's save that. Alright, now let's take a look at this. For now it's black. Oh wait. Okay, I'm using this, I'm using this, I'm using that. Alright, this is strange now. 0. Oh, okay, wow. Oh, then this means I need to like reset then. This is like the biggest headache. Like no errors, but it's not working. In this case, the final color is this. ID to color. So we have all the colors and an ID. And then distance matrix. Distance matrix. Okay, forward distance multiply by that. Four by 4, then let's take a look at that. Okay. Let's try to return something weird. Say forward. Oh wait, let's return final decision. X X X X. Hold on. There we go. Okay. Color 7. Oh boy, okay. Let's scatter the point across first. So in this case, 0, 0, 0, 0 over here, and then 0.25, 0.25, 0.25, and then 0.25, 0.5, 0.5, 0.5, 0.5, and then 7.5, and then we have 7.5, and then we have 7.5, and then we have 7.5, and then this one is 0.5, 0.75, and then this one is 0, 0.25, 0.5, 0.75, 0, and then 0.25, 0.5, 0.75, and then 0, and then 0.25, 0.5, 0.75. Okay, it does change up a little bit, so let's set all of them to 1. Oh! Now this is something interesting. Zero. Oh, it's the last one. And then the last one, the color is white. But it is signed distance. So that's the weird thing. So let's head back to 0.75. Okay. So, distance matrix. UV xy point xy So distance matrix that will return. Also, no wait. That is a distance. Oh wait, it's because I'm returning that. Okay. Then let's see how it behaves when I do this. Okay, this is using Voronoi. Okay. Or oh, okay, I'm doing the wrong stuff. Instead, it should be this. Okay, then it's still back. Point A, point B, return a float. So 2 and plus to the 2. Now let's take the whole thing to the power of 0.5. So that returns distance. Oh boy. Is there any way that I can debug my shader? Let's see how it comes out, or see how it works. Oh boy. Let's see what it says. If that doesn't work, then well, time to make our own struct. Here we go. Oh no. What should we call it? What should we call it? This is so weird. Fine, let's call it A. And B. We are making our own struct. I don't care. Oh boy. If A is 1, then we need until P is 16. So yeah. Whoops. Let's see if it will that even work? Unexpected token sampler to the 106. Oh yeah, it's a struct, so we need that. So yeah. Damn. This is so weird. Like, we just end up with our own data type. So it's SOWO float 16 from A to P. And well, here we go. SOWO float 16. This is a weird one. Let's call this array. Oh wow. SOWO float 16. Let's see, will that even work? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Constructors only defined for numeric base types. Two to 6, which is this one. Turns out that didn't work. But this is a struct. Oh boy. I don't even know what to do now. Are we going to use the stupid way? Because this 4x4 matrix is something new relative to this, so oh boy. Like, I'm just looking at this and I have no idea what went wrong. And it's just like pure black. Oh, all of them are one, meaning we are using them. And then we have all these colors. You know what, let's make one more color. Let's call that color wrong. And then wrong color. C0W. Color wrong. There we go. It returns that. It doesn't even change. Huh. So, meaning it keeps on returning number 8. And number 8 is 0 and 0.5, which is down here. Oh boy, this is getting hard. Or is it really this? No? Okay. Oh! Oh, so meaning it keeps on returning the very first color. Huh. No matter where it is. It keeps on returning the very first color. UV X. That's the first vector 2. Or I should say this over here. Float 2 and another float 2. keeps on returning... Okay, so if it keeps on returning this, then... You know what? I'm going to try something dangerous. What will happen if I type that? Will it run off? Oh. Let's see what it says. Array index out of bounds. Okay. So yeah. It's from 0 to 3, ZX to W. If I set this to 1, or maybe 2, that will change into something else, I believe. Aha! So meaning, whatever it does, it keeps on returning the very first point. If. Else if. Purple all over the place. Should it happen like that? Let's take a look at other queasy shader stuff. Because we also use a bunch of if-else statements over here. So if we were to take a look at that, then... we have if, and then we have else if as well, but with the parentheses close to that thing. Oh wait. Huh. Okay, we'll take that into consideration. But look at this. If this thing, then that thing. So meaning this is fine, okay. And what's the distance? 0.0, 0.4, 0.8. VEF. Those are vector 4. Capital P. Like the hardest part when it comes to like shader debugging is like it's running, but it's wrong. That is the hardest thing to fix. That 0 This is why I always say is that I'm not like smart or something, because if I were to be smart, this thing would have been running. But if it takes in a float core, does this mean No, okay. So that is not the problem. Well then. Oh boy. So with this, it's going. If I were to do this again, then where is it? Then if we go back here, then we'll have that. Which is something weird though. Right, take a look at that. That one is number 8. Is it? Or it's the last one. Yeah, it's the last one. It should be like the color is we have this distance and then final decision. Oh, it outputs that. So it needs okay, so it outputs min distance, which getting closer is 0, further away then brighter. Okay, and that is correct. And, so final decision. But what is the ID? So do we have to like float? Let's call this final color. It's a fixed 4. Forward to ID card, so X, D, and then we have that. And then we will return final color. First of all, is it color wrong? No, it's not color wrong. Yeah, it's the first color instead. Does it take an alpha? No, it doesn't take an alpha. If it doesn't take an alpha, wait, hold up. Hue transparent, render type transparent, forward based. Multi-compile fog. I didn't ask for that. Oh. Comma expression used where a vector constructor may have been intended. 151. Let's see, what's the next one? Output value birds is not completely initialized. Potentially unintended use of comma expression in the variable in 205. Let's see. Go 5. Hold up. Alright, then we'll come back to this. Now it works! Oh, oh my godness! Oh my godness. Just because I didn't say it's a 4x4 float, then shader code is like, huh? Oh my godness. Jeez. Anyway, we need to like make sure that everything is correct. So Oh boy. In this case, you know what? Let's reset them. Okay. So we have RGB whatsoever. R G and V. Whatever, we have these three colors. Up, there we go. Ho 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 ho. Look at that. Look at that. It's working. Oh my godness. The next color is, let's choose this kind of yellow, shall we? So, okay. Point 3 is not exactly working. Okay, let's have 0.1. Or okay, let's choose another color. No? Okay, let's take a look at number 3. Because color number 3 looks sus. 2, 4. 3. Then that needs to be 3. Then 4 should be down here. Alright, let's save that. There we go. So yeah, Voronoi. Oh no, finally made it. Oh my godness. Oh, jeez. The next color, let's go with, you know what? Let's choose a perfect color palette, shall we? So, let's see. What's a perfect color palette? We will decide it from here. So, alright. Wait, how do I minimize this thing? There we go, F11. Okay, now, back to this. First, let's just choose our colors. Sorry, oh boy, by using our own eyes. And then we have this. And then we have this. And then we have vermilion. And then we have red. Once we have red, we are going magenta. And then going to magenta. Wait, let's bump that up. Once magenta, we are going to choose purple. Oh wait. Number 16 is black. This one over here we have navy blue. And then after navy blue we have azure blue. And after that we have this cyan. So and then the rest of them are just gray tone. Let's go with 75. This one is, let's go with 50. And then this one is 25. And then we have that. So until color number 7. Alright, let's have that. And then oh wow, just look at that. Look at that. Oh boy, this is good. Oh wow, so now, yes, we have Voronoi. Okay, so this is the basic stuff of Voronoi. Now, the second task is how to like have sharp edges. That's the problem. So, where the sharp edges happen, let's see. Basically, if we find a sharp edge, then okay. When we find a sharp edge, this means there are 2 points which are nearest to us. Then it will be colored by that. How can we have an edge? That's another problem. But anyway, since we've got the color palette, now let's set them up in the shader. So, boop. And then let's go with, yep, you can see me over here, so in there. Alright, okay, there we go. First one is white. So second one. Oh wow. Hold up. 5765. Oh wait, let's use RGB instead. Huh. Um, 255, okay. 247, alright. So we have 247 divided by 256. And then we have 90. Okay. So 90 divided by 256. And an alpha of 1. Next we have also 255. And then 192. Okay. 192 divided by 256. And then we have 0 on that. Okay. And then 1 there. Okay. This one 255 as well, but 140 and then 0. So 140, 256, and then 0. And then hold up a second, let's save it and then see if it has any problem. Oh wait, it cannot take that as input? Oh wow. Oh wow. Nasty. Nasty. Oh wait, we need our calculator. Let's bring out our calculator. So, 247 divided by 256. Let's take 4 decimals. Okay, the next number is 90, so let's clear this. 90 divided by 256, and then we have that. Okay, next one is 192, so 192 divided by 256, 0.75. Oh, okay. And then the next thing is 0. Okay. And then cancel that, because the next one is 140 and 256. There we go. And then let's just save that, and then let's return here. Oh boy. Well, one, two, three, four. Then we need a different workflow. 255, 85, and 0. Okay. Color number 5 is just, yeah. Oh, let's choose that. 255 all the way. Okay. Color number 6. Oh, we have a 314, 134 down there. Okay. Hold up a second. This is color number 6. 134. Okay. Okay, now color 7. 233. Alright, color number 8. 166. Oh, at the red. Okay. And then color number 9. 118. Okay. And then color A. Oh. Okay, 50, then 202. 50, 202. 132, and then, yeah. That is for B. Now, C. Oh, yeah, full plus on that one. Alright, now D. 191, okay. E is 128. And then color F is 64. And then this one is just like all 0. Alright, so now let's turn this thing into decimals because, well, shaders can't crunch those numbers. Okay. So, the first thing we need to take care of is all of these are 155 as well, so they're like full power. This one is also full power. And this one is also full power. And then, yeah. The next one is 85. So, clear. 85 divided by 256. Get the first number. $85. Boom. There we go. And then that one is 0. Okay. Okay, so that's considered done. This one is also all 0, meaning pure red. This one has no green. 134. So let's have that. 134 divided by 256. Yeah, that one. paste that. And then comma 1. There we go. 223. No, 233. Alright. So 233 divided by 256. Then we have this. 0, so it will be 0, 0, 0, 0, all the way. And then we have that. And then we have that. Now 166, so cancel 166 divided by 256. So we grab that. Um, 118 cancel 118 divided by 256, and then we have that. And then we have 0, and then we have, oh boy, we have 50, so cancel 50 divided by 256 is this. Alright. And then 202, so clear, 202 divided by 256 is that. 202 is the last one. So it will be that one. This one is 0 in the middle, and then 1. Zero over here, then we have a 1. We have 50 over here, we have 202 over here. And then we need 132, so cancel that. 132 divided by 256. Okay, the first 4. And then 256. Okay. And then, yeah. First one is 0. All of them, and then 256, which is 1, and then all of that. Next one is 0 that, 1.0 all of that, 1 point that, and then this one is actually 0.75 and 0.75. 0.75, and then this is 0.5 for all of them. And then this one is a quarter for all of them, so 0.25, 0.25, and 0.25. There we go. Now, let's remove these. Alright, there we go. Oh boy. So that sets the panel, the palette. Now, once we say hit reset, oh boy. Oh wait. Ah, okay. I know what to do. Instead of that, we will say 0, and then 0 for the first 4, and then that for the first 5, and then 7 for the others. And then, starting from here, we have that, then we have that, then we have 7, 5. This one is 0, and then 2, 5, and then 5, and then 7, 5, and then 0 again, and then 2, 5, and then 5, and then 7, 5, and then 0, and then 2, 5, and then 5, and then 7, 5. So there we go. We have that. Alright, fine. To make things more clearer, let's align them. Point 0, 0. Point 0, 0. 0. 0.00 0. There we go, and yeah. Alright, now let's get back here, and then let's hit reset. So we have this, which is fair, but once we start bringing in new colors, you can see there we go. So yeah, because basically these are where the points would locate. And then yeah, like you can hop between different regions and then you just go crazy with that. Let's say if I were to like choose this, that you can see that I'm like moving around. So you can see like squish, 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 blop, blop, blop. It's actually quite fun looking at them go. So 0, 0. Now the problem would be something like, how are we going to let those points move? So this is the problem. Now question would be something like, what can we get from the time variable? So that's something. Well, let's see. Because once we got that, we can like calculate the offset of every point, and it can be calculated. So that's the good part. Because the only problem is, you are not allowed to bring one information from one pixel to another pixel, I should say. One fragment to another fragment. Oh, new walkade. So far we're doing good, and yes, we are writing shaders. Oh, hold up a second. Why did that appear twice? Huh. Why did that appear twice? Strange. Well, time to debug that. Let's see. Okay, this one shows up here once. And then for the brunch. Well, let's take a look at this. Huh. Scene brunch. Green brunch. And then for screen brunch, we have overlay doing. So let's not have that. And then now let's go back here. Alright, so yep, as you can see, Kate, we are writing a shader, a Voronoi shader. So basically you can do cute stuff, like you can see this like white square is like squishing between the regions, which is something cool, I think. Now the only problem is you don't know when you will use this. However, we are going to write something really interesting. So, alright, let's move that back to position 0, 0. Alright, now, let's go back to this. Now we just need to figure it out a way to interpolate between different random numbers. So let's see. Okay, so we will work on another function which we will call return random or something. But basically we are going to use a lot of trigonometry in this case. That gives us something smooth. So let's go for let's say it will return a float. And then we say for wall again. Let's go with sine to random. So let's go with Okay, let's have a sine wave. What does a sine wave has? It has a phase. It has a phase. To add to an angle, and then take this whole thing, multiply it by a frequency, and then we have an amplitude. So so for every... Okay, let's go with 4 sine. 4 sine to random. So we have... we will basically take in a bunch of vectors again. Okay, so we're going to take vectors inside again. So float 4. And then we will call this wave 0. Another float 4, wave 1. Another float 4, wave 2. And then another float 4, wave 3. So now a single wave can be described as a vector, which is weird, but yeah, doable. Now let's see. So the amplitude. Okay. Alright. X is phase. Y is the frequency, which is frac. And then Z is the amplitude. Now for W it's gonna be nothing for now, so just in case if we need to put that into good use, it's right there. So angle, let's see, let's go with time and then 1. Or let's take a look at what does it says. So if we open up a new tab, Unity shader. Oop. Alright, fine, we'll have that. Unity built-in shader material. Not materials, variables. Up there we go, time. Oh, we have t divided by 20 and t times 2, t times 3. Huh. Okay, so t times 2, t times 3. Fine, we will use t. Okay, so we have this. Now, frac would be something like wave 0.y. Phase would be wave 0.x. And then amp would be wave 0.z. And then this is what we have. I will call this. What should I call this? Let's call this R1. And then it's gonna be a float. And then oh wait, it should be R0 instead. And yes, this is where Fourier transform might come into play, but that is not the original intention. However, we can actually try to do that. We'll think about that. We'll think about that. Wave 1, wave 2, wave 3, and then wave 3, wave 2, wave 1, and then wave 1, wave 2, wave 3, and then float. Oh wait, or I should say return. R0 plus R1 plus R2 plus R3. So we will have that. Well, not exactly random though. But basically, it just lets them oscillate around the place. Oh wait, it can like oscillate along X and along Y as well. So, oh boy, how many waves are we going to need? So this means every wave can like move. You know what? Instead of that, we are not going to use this idea, but it's a good tool that we can put aside, because the next thing we are going to do is to have a texture to distort the UV location of those points. Yeah, okay. So what we will do is, oh, here we have a sampler 2D. Good, perfect. Let's cut this. I will not call this main text. I will call this point, this distort text. So we have that. And for now, it's gonna be black because there gonna be like no offsets. All right, so we have that. Now, okay, this is going to be a little bit weird. Okay. So, plus some kind of offset. If it's were to be some kind of offset, this means that we need some sort of like scrolling or whatsoever. So let's have this. Point distort, I call the image. And then point distort transform. It's just going to be a tr pause of x of y scroll x scroll y. It's gonna just be this, and then it's going to be a vector. No scrolling, no offsetting. Are we going to have a rotation? Yeah, I think so. You know what? At this point, we are just gonna like... Are we going to bring in some queasy shader stuff into this thing? No, I think we're just going to do something like the built-in stuff. So, we are only to care about... some scaling. So we have TRSCL, scale X, scale Y, null, null. Alright, and it's also a vector. And then scale is 1, null is 0. So we have these. And yeah, alright. Alright, so distance matrix. We will plus a text 2D from our point distort image with a UV, and this UV is oh boy, 0.00 XY. Plus the offset. Are we going to call it that way? Because trend. Alright, T pose and T scale. we are going to have that. And also, I almost forgot, we need to declare it over here. So sampler 2D, point distort image, and then we need a vector, point distort pause, and point distort scaling. So we have that. Now we have these. Oh wow. Text 2D. Point distort image. Forward distance thing. Point of X, Y, and then just point distort T pause X, Y, and then take this whole thing, multiply by point distort oh boy, it's gonna get complicated. Alright, fallback. Alright, let's make a simple function. Float. It will return a fixed 4, and then we will call it full read from texture fixed. So what will it take is a sampler 2D, which we call that image, and then we have a vector, let's call it T pose, and then another vector which is T scale. So what will it do is read from texture fixed. Wait. Okay, then it will give you float 2. Distort from texture fixed. So and then we also need a vector, let's call that power, for each channels. So we will do that. Now read from the texture, so it's text 2D from image Once we got the image, then we will need our tpos dot xy plus tpos dot zw, but of course like multiply by time. One. Okay, so we have that, and then gets multiplied by t scale dot x and y. So something isn't right. Okay. Let's have that call float tool, and then we will say in UV, so which is the incoming UV. So in UV, that is a float tool. So in UV gonna get offset and also gonna get scrolled and gonna get scaled. Okay. And then we got the color. So fixed for of read color is this, and then return read color. Oh wait, okay, let's say float for. Oh wait, we're going to do it the straightforward way. Okay, so read color dot red multiplied by power dot x plus read color dot g, and then power dot y plus read color dot z plus power of z, and then plus read color dot a, and then plus power of w, and then it's just gonna, oh wait, let's say this is power x, and then vector we have power y. So final power x, so power xx, power xy, and then power xz, and then power xw. We have that, and then this is a float. Then we can say float final power y, and then we have read color of r, power y of x plus read color g, and then we have power y dot y, and then we have read color of z. Oh wait, something is missing. It's not plus, it's multiply. Okay, and then multiply power y, and then z, and then read color, and then a, and then oh, it's not. Oh, it's multiply. Okay, multiply, and then power y of w, and there we go. And then we'll just need to return a float 2 with final power x and final power y. Oh boy, that's a lot of stuff. So, oh boy, this matrix is going to get messy. Okay, so let's plus. Let's call forward distort. So read from texture fixed. And then what we will have is let's split the window, and one on the upper part, one on the lower part. So we can see what other variable names are. There we go. The first one is the image, which is this thing. And then the second one is the incoming UV, or I should say it's gonna be the point UV. So it's gonna be dash point 00 dot xy. And then the next thing is transform and the scaling. Transform and the scaling. And then, oh, we need two sets of powers, so let's have those set up. So over here we need point distort pow x, distort, let's say power x, along RGBA, and it's a vector. By default it should be none of them. Another one is point distort pow y, and then power y RGBA, and then vector, and then 0 all over the place. Now we have that. Now we just need to declare that down here. So it's another set of vectors. Point pow. Oh no, okay. power X and point distort power Y. There we go. So we have those. Pause, scale, and then we have power X and power Y. Control C. Paste that in. And then we have that. Okay, I think we got that one. Okay, so let's close that, and let's close this, and then let's save that. Oh boy, this is a long thing. Okay, fine. We'll write stuff this way. Oh wait, I think I got it wrong. It should have been here. Okay. Now. And then we'll just give a few space bars. And then we will just name them. So 1, 2, 3, 4, 5, 6, 7, 8, 9 cap locks A, B, and C, and D, and E, and F. Pause, scale, pow, pow, and then we have that. So let's go back to Unity. Okay, let's see what it says. Unexpected token float 202. Oh, probably a missing semicolon or something. 202. Yep, it is. Alright, back here. Undeclared identifier. Oh. 239. Huh. Oh, we have all of them now. Okay. There we go. And then... Alright. Now, here is the weird part. Let's say if we go with another purlin noise, or yeah, here we have purlin, and then let's have, oh, you can see that already. You can see that already. 0.25, and then let's go with, I don't know, 0.1, I don't know. And then let's have that scroll along X. So now we have this. Yay! Oh wow, this is so weird. Let's have it 0.5, 0.5. What would happen if it were to be? Oh, yikes! Yikes! Okay, this is beautiful, yes. .5 over here. So yeah, we have this. Oh wow, this is so cursed. .4, 0.4, there we go. And let's have 0 for that. Oh wow, this is so weird. It's like you have jelly or something. Oh wow. But yeah, this is Voronoi. What would happen if we put Voronoi inside Voronoi? Let's see. uh, can we find that? Voronoi inside Voronoi. Let's go. Yep, it's pretty cursed. Yep. So yeah, we have this. So yep, this is specific Voronoi, and now the problem will be something like, okay, fine, we can have a render texture of this thing, and then, oh boy. But actually, we can actually implement this into Queasy shader. So, yeah. Like, as you can see, if you dig deep enough, there's this like glitter layer inside Queasy shader, which is also one of the function-specific ones. So, but yeah, Voronoi is one of them. Now the problem would be something like how can we like make the edge? Because that's the problem. We still haven't fixed that yet. Yeah. How can we add edges? That's the problem. Wait, I have an idea. I have an idea. I have an idea. Wait. Okay. I think I know what we can do here. So, X, Y, Z. The last one is radius. So by default, radius is like very big. So maybe something like 4 or something. So okay, so basically before outputting the final color, we will say if that position is still inside that radius. If no, then we will output black. If yes, then we will output that color. So we have final decision Y. So let's see. If final decision of X is smaller than that radius, then how are we going to get that radius? We have the ID. Alright, let's see. ID to color. Let's see. ID to color. 4x4 min. So let's take a look at that. We can return the minimum distance and then the ID. Oh boy. Because I'm thinking of we can use exponential powers to like crank the colors as it's like getting further and further away or getting closer and closer. It's almost something like Fresnel ramping. but slightly different. Let's see. If final decision of y perhaps the final color needs to be done inside the function itself. So this float. Let's call it get radius. So okay, float 4. Let's call that point something. So P that. So we will duplicate that. And then paste it along down here. And then we have E1, P2, P3, P7, P6, and then P5, P4, and then we have P8, and then we have P9, and then we have PA, which is 10, and then B, and then F, and then E, and then D, and then C. There we go. So get the radius as well. So get radius will be P00 of the last one. So we finally put that into good use, which is the radius. And let's paste this thing across. Yep. There we go. Alright, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. There we go. So we have that. Once we got the radius, Oh boy, we need to like ask if we want to like flip the region though. So let's add one more. All wrong. Flip region. And then it's gonna be a range 0 and 1. And by default it's 0. Now here let's have it this way. So it's a float flip region. So we have that. And then oh wait, here we are. Okay. Call this thing flip. Okay, so we have that. So final color is that, get radius is that. So let's say I have the ID and I have colors, and then I can have the radius. So incoming ID. What will it get from final decision? Min distance, point ID, dot dot. Feels like we can like snuck in a few parameters in there. Oh boy. So get radius will be a certain number, and then that number can be something like a ramp or something. but in this case we need the distance. So in this case it's forward distance again. Between 2 points. Let's have a float tool called get position. For now, float 2 is 0, 0. And then get position equals e00 dot xy. And then we can have that. There we go. Okay, good. And then just 1, 2, 3. Oh wait, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, and F. So we have that. So, you can have the distance. So, forward. Hold up a second. Incoming ID. Let's have a float tool. Let's call it in UV. So forward distance min distance. Can we use that? Wait, it's the distance. Alright, fine, let's have that. So in this case, it's not gonna be in UV, instead it's gonna be distance. Okay, because we have that. So we have distance. Okay. Distance is a number. And then we're going to map our distance from x-axis to an output. So distance minus flip and then let's power this thing up with get radius. this is our final number. So final color equals final color multiplied by that, and then we'll have that. So in this case we don't need this. Fine, we'll have that. Probably something weird gonna happen. Alright, let's see what it says. And expect a token that. Oh, probably I'm missing a bunch of commas. There we go, yep. Bunch of commas is missing. Oops. There we go. Oh wait, or is it? No, it's not it. Then if that is not the case, then 176. Oh wait, we haven't bring in those stuff in yet. Color wrong, then it's all the points. Yeah, we'll have that. We have 2, and then we have 3. Four, 8, C, D, 9, 5. And then we have 6, A, E, and F, B, 7. Final decision Y, which is the incoming ID. Need flip and distance. Flip and distance. Okay. Flip and distance, which is final decision of X. It's gonna stay pink, definitely. 176. Oh, semicolon is missing. There we go. An inspector token return 1970. Oh, okay. Get back here. Alright, now here's the weird stuff. If all of them were to be whoa, you can already see it coming. Oh, Oh wow. Oh wow. Okay. Um. Hmm. The flip region doesn't work well. So flip. It's either 0 or 1. So okay. So it's actually 1 minus. Oh wait, no. Hmm. Hmm. Distance. Hmm. So this. Hmm. Hmm. Distance. Hmm. Oh boy. I'm thinking in lerp now, but hmm. Flip, flip region. Hmm. Hmm. Well, it's not necessarily gonna be 1 or something for the full value. That's the problem. Um. It needs some sort of full value. But let's just say we don't want to flip it for now. Let's see if that will do something. Um, okay. Hmm. Let's add a new stuff. The region. Let's call it color ramp. And it's a float. By default, it's 1. And then final color RGB is actually final color dot RGB. I don't know if I can do this. Like, this is perhaps doable. But yeah, I will need to declare it somewhere else. So, float color ramp. Oh boy. Maybe this is doable, maybe it's not. Oh. Okay. Okay. But yeah. Okay. Not quite sure what will it do now, but at least we want our basic stuff. Or I can say basically it will be something like if min distance is like smaller than radius, then get color, or else get black. So basically it's something like that. So we have distance over here. if distance is smaller than radius, then final color is still final color. Otherwise, final color is black or something. Wait a second. Hey, we can use Newton's gravitational function as inspiration. So it's divided by distance squared. Final color multiplied by okay, a constant, let's say 1, divided by distance, meaning if it gets closer, then it's closer to 1. If it gets further, then it's getting closer to 0. Yeah, we can try that. So let's try this. Oh, what does it say? RGB. 205. Too bright. Let's say all of you have a distance of 0.1. Oh boy. Well, I have to say, this is enough to light up my whole room. Well, that looks fun, but that is something what I'm not expecting. Are we even using color ramp? I don't think so. So distance, which is the last one though. The last one is that. This last one is the distance. So if the distance is smaller than the radius, then final color is final color. Hmm. As the distance gets further, but if we take a look at this, this is like, huh. Get multiplied by 1 divided by something. So distance can be, oh, distance can be very close as well. Oh, that is some kind of problem. Alright, in this case, we will need to choose max. Max of that. To clamp it. Okay. When distance is small. When distance is small, then this will bump up, so it will choose that. So it should be min. But if this is smaller than 1, then we'll choose that. Okay. Oh. That is something. So 0. Let's go with 1 divided by 16. Let's go with that for all the points. Although it is doing nothing right now. So, if the distance is smaller than get radius, then color is color. Otherwise, if it's outside, then it will get affected. And then min. This gets too big that it will always choose 1. Wait. The distance we can have. Is always somewhere around 0 point something. So if it's going to be 0 point something, then this will always be bigger. So we need to make 1. So we need something smaller than 1. So in this case, we don't need flip for now. Let's call this distance full. So we have distance full. And then down here we don't say flip region, we say distance full. And since we say distance full down there, we need to like declare it distance full here. And we also need to say distance full, and we also need to say distance full, and not a range anymore, it's a float, and distance full for now is 1 by default. So distance full needs to be like lower, so 0.5. Oh, 0.5 or aha. Now this is interesting. Hehehe. So yeah, now we have this, and it actually looks cool. You know what? I'm satisfied with this. Oh boy. Well, it looks fun. And I believe how long we've been streaming? 5 hours. Oh wow. Alright, I'm definitely stopping the stream over here. But don't worry, I will upload this onto GitHub. Now, question would be something like where on GitHub? Where can we get this? So what we are going to do is we will go here. In this case, I will just like copy and paste the link into the chat box, so everyone can have that. Oh wait, what? Okay, this is a little bit weird. Okay, you know what? I am going to go to Twitch and then just type it there or whatsoever. We are going to hear sounds, so let me mute the site. There we go. Alright, and then we are going here, and then alright, what I'm going to do is just paste in the link. And there we go. So that is the link to get the stuff on GitHub. So let me close this thing. Alright, let's get back here. Alright, so in this case, that will bring this to our main website. And oh boy, it appeared twice again. Screen brunch. Chat box. Aha! Okay. Screen brunch. There we go. Alright, so that link in the chat box that will bring you to this website, which is our website, our official new website. So what you're gonna go here is go to art, and then once you go to art, you go right, and then you go right again, so you end up in the 3D section, and then you go here, virtual reality or VR, and then you go in here, and we'll end up here. So here we will, you know, do Blender, Unity, and VRChat stuff. And then over here is the button, Quasi Shader 3.0. Afterwards, I will put other stuff inside here as well. So over here, you can just like start downloading and go give it a try, or whatsoever it is. But yeah, basically this is what we have today. Voronoi! Cute Voronoi. Well, anyway, if you're watching this to the very end, thanks for watching, and I'll see you next time. Not sure when, but yeah. Maybe next time it's inside VRChat, or maybe on Unity, or maybe writing shaders, or guess what? Or maybe in Quest 2, I don't know. But anyway, see you guys all in the next stream, and bye bye. Yeah.